This tutorial will show how easy it is to perform an analysis of stage construction using the nonlinear capabilities of SAP 2000. We start with a simple 3-story 2-bay frame, where each story will represent a stage of construction. We will remove the center first floor column in order to create a transfer girder. This girder will be susceptible to stage construction because it carries gravity loads from the floors above. The key to doing stage construction in SAP 2000 is to identify each stage as a group. In this case, each story or stage will be represented by a group. Repeat this process for each story, selecting and then assigning the objects to a new group. Next, we define the static load cases. For this example, we will use only the self-weight dead load case. Next, go to the Define Analysis Cases. We will delete the predefined modal case as we will not be doing any dynamic analysis. To the dead load case, we will add an additional case for the stages of construction. Name the new case Stage Con, and select the nonlinear stage construction option under the analysis type. Make sure that the 0 initial conditions is set, and add 3 stages under stage definitions. Highlight Stage 1 and under the Data for Stage 1 area, click Add Structure in the Operation drop-down list. Click Story 1 in the group list, and then hit the Add button. Go back to the Operation list and click Load Added in Group, Story 1 in Group, Load in Load Type, and Dead under the load name with a scale factor of 1. Click the Add button to add this to the list. This tells the program to first add the structure and then the loads for the first stage. We repeat this process for the other 2 stages, adding the structure and then the load. Click on the Modify Show button for the results saved and select the End of Each Stage option. We now have a linear static dead load case and a nonlinear case representing the stage construction of the 3 stories. Now that all the analysis cases are defined, we are ready to run the static analysis. Change the 3D view to an elevation view with the dead load case displayed. In the right window, we will display the deformed shape from the staged analysis cases to see the effect that this loading approach has on the building. We select the Stage Con case in Step 1, which is at the end of Stage 1. Add the next story with Step 2, and then the top story with Step 3. A right-click on the middle joint for the linear case shows a displacement of about 1 inch. While the same location in the nonlinear staged analysis gives a result of almost 2 inches, nearly double. Next, change the left window to show the moment diagrams for the linear dead load case. In the right window, we will again show the results for the stage construction case, starting with step 1. We can toggle up through the steps to see how the moment changes. At step 3, the last step, the moment in the transfer girder jumps to 1492 kip inches, more than double that of the linear analysis where the entire structure works together to span between the columns. This concludes this tutorial.